Hi, my name is Nuri Kashina binti Sharif. Today I will present about introduction, bridge dimension, and model drawing. For the first one is introduction. The aim of this project is to encourage students to apply the knowledge of structural methods and to solve problems by designing model of a bridge, which is railway bridge, and fostering communication between groups. So for the second one is model dimension. The overall length of the model is about 10 meters, and clear span between edges must be 8 meters, and maximum overall length width 2 meters, and maximum overall height 3 meters. Contact face area 2 meters times 2 meters. The uniform distributed load on bridge is 2000 kg. Overall length of bridge. Size of I-beam for all member bridge is universal column 305 times 305 times 280 mm. For model drawing, we're using AutoCAD. So there are 4 elevations for this model. The first one is line elevation. Second one is front elevation. Third one is left elevation. And the last one is right elevation. So for equation, for this model, we use equation m plus r more than or less than or equal to 2j. This equation to determine stability of the model project. For this equation, m is members, r is reaction, and j is joints. So we insert the value to this equation, and we will get m plus r equal to 24 and 2j equal to 27. So for the equation, we get m plus r equal to 2g. For the result is stable or our model drawing is stable or determinate trust. Thank you. That's all from me.
Hi, Assalamualaikum. My name is Zulaika. Today I will show you how to design bridge using LinPro. First, we take this member, then we just put it, and then you just right click and member, just like this. And then you put support at here. Okay, and then you release each member. For example, this, release it for the moment. And then you go to here to release all. Here. This is the area, the red one. We just manually this. Okay, after that, we just put the loop here. So, then right click, add load. And here, the load is -19.6. It will become like this, and then just click here. So this is, so then you just print it. So this will be the report. So this is our design.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Mishdalaki bin Muhammad Zahir, and my metric number is AA191808. And now I'm going to talk about my part of the project, which is the manual calculation of our bridge. Now first, let's take a look at our bridge design right here. We have UDL with a length of 10 meters, and this bridge is simply supported, and this is how the trusses looks like. Okay, now the first part of the calculation is to find the reaction that supports. In order to find that, we need to apply the equation of equilibrium. which is total moment equals to 0, total Fx equals to 0, and total Fy equals to 0. We got the value of this, which is 98.1 kN and upwards. Next is the total forces in the y direction, and then we got RBY equals to 98.1 kN. Since there are no forces acting on the horizontal direction, RBX is equals to 0. Now to the second part of the manual calculation, which is calculating the internal forces using joint method. First, we need to draw the free body diagram with all the forces and reaction forces and also the UDL. First, we need to convert the UDL to point load by using bending moment and shear force diagram. So we got these value right here. Then we try to find the angle from this two trusses and also this trusses right here. So let's start at joint A. In order to find the forces inside this joint, we need to apply this similar method as we did before, which is the equation of equilibrium. Only this time we don't apply the total moment, only Fy and Fx. So we got the value of FL is 10.34 kilonewtons, which is in tension. Next, for the total forces in the x direction, we got FAB equals 3.27 kilonewtons, which is in compression. Next, for joint B, we apply the similar method as before, and we got FLB equal to negative 68.69 kilonewtons. We got the value of FBL equals negative 3.7 kilonewtons, which is in compression. Joint L, we got the value of FLC, which is 70.76 kilonewton in tension, and for value of FLK, which equals to negative 35.98 kilonewtons in compression. At joint C, we got a value of FCK, which is equals to negative 19.5 kilonewtons in compression, and we got a value of FCD, which is 5.59 kilonewtons, which is in tension. Next, for joint K, we've managed to find force AHD, which is equals to 23.44, and for the x direction, we find a value of HJ, which is equals to negative 48.98 kilonewtons, which is in compression. At joint D, we got FDJ, which is equals to 19.72 kilonewton in tension. A value of FDE equals to 348.89 kilonewtons, which is in tension. For joint J, we managed to find the value of FJ, which is negative 23.7 kilonewtons in compression, and then Fij, which is negative 35.83 kilonewtons in compression. For joint E, we find FIE, which is 58.94 kilonewtons in tension, and FEF, which is 35.74 kilonewtons in tension. Joint I, we find FIF, which is negative 70.84 kilonewtons in compression, and also FIH, which equal to 3.46 kilonewtons in tension. For joint F, we find the FH member. For joint F, we find a member FH, which equals to negative 9.74 kilonewtons in compression, and FFG, which is equals to negative 3.55 kilonewtons in compression. Okay, now let's move to joint H. We got FHG is equals to 10.27 kilonewtons in tension, and finally for joint G, we already know the value of HG and GF, which is 10.94 kilonewtons in tension and negative 3.55 kilonewtons in compression. So this is all of the forces, all the internal forces that we have found, and that's all for me. Thank you so much.
Hi, I'm Sarah. I'm going to present about recommendation. So how to improve the bridge load carrying capacity. First, use shaped triangles. Shaped triangles are really strong shape for building because when we put force with all sides, it makes the shaped triangle more sturdy and stable. Secondly, use cable to make suspension bridge to make the bridge become more stronger and can carry more load and long lasting. Thirdly, make sure the force, compression and tension always balance so that when the bridge receives a lot of load, the element of the bridge can process the force in the best way. Next, use ultra high performance concrete at connection point at the bottom of the bridge. Last but not least, we need to use carbon textile reinforced mortar for base bridge.